Newsmaker Sunday with Fox 10's John Hook.
Thanks for joining us on Newsmaker Sunday. We are going to talk climate. We're going to talk Patricia, the hurricane that is battering Mexico, with a guy who knows this all too well. And we'll also talk about Arizona, what's happening here, and whether we're entering maybe a wet period. Randall Cerveny is a president's professor, ASU Climatologist Randall Cerveny, longtime guest on the program, and right behind you as we take a wide shot. Patricia, before landfall, tell me what you see when you see this right here. One thing is the eye. It's unique, isn't it?
One of the interesting things about this particular hurricane is the intensity of it. As it's making landfall, as we see in this particular picture, we're talking about winds that are in excess of 200 miles an hour sustained. That means that they aren't just the gusts that last for a couple seconds. Sustained means lasted for an extended period of time.
That's catastrophic damage.
Yeah, and if you get hit, even if you're in a cement building, you're going to take major damage from this kind of
Now, when we see this, the rotation is going clockwise, right?
Counterclockwise.
Oh, I'm sorry, yes, counterclockwise. Yes. So the strongest part of that would be the north.
What we call is the upper right-hand quadrant.
Okay,
so,
upper right-hand quadrant.
So as we're looking at it there, it's going to be the place that is to the right of that eye and a little north of it.
That's the brunt.
That's where the strongest winds are going to be.
How much of this is tied into El Nino?
Pretty much all of it, because the idea is that this Pacific Ocean this year has been incredibly active, which is a very common situation during El Nino years. In contrast, the Atlantic, we've hardly had any major hurricanes. We've had only one major hurricane that was in the Atlantic this year. The Pacific, we're still counting. I mean, this particular storm that we've had over the weekend here is just one of what will probably be still more to come in the future.
We've got a machinery working right now to bring us weather.
Yeah, and it's called El Nino. It's this idea that we have very, very hot water off the coast of
You
South
called
America.
it boiling in your before. In other words, relatively, it is really, really warm.
It is this year. It is one of the most intense El Ninos. It's some of the warmest temperatures that we've seen in the last, say 3 or 4 decades. We're not talking just years. We're talking that we haven't seen anything like this since back in the 1980s or even back in the 1950s.
And we had wet periods then, so it figures.
Right.
Why is it that warmer Pacific water produces this? What is the reason?
Well, storms in the area around the Pacific are fueled by hot water. Hot water provides both heat and moisture, and those are the two critical elements to create a good rainstorm over, say, the Southwest here. So during El Nino, when we have really hot temperatures there in the equatorial Pacific, it can evaporate a whole lot of water. The hot water evaporates into the air, and then that moist, hot air gets pushed over Arizona, gets lifted up, and creates big rainstorms.
Do you suspect, after all of this discussion we've had about California drought, that we will not be talking about that at this time next year, that they're going to get pounded?
Well, they're going to get pounded, but the trouble is with the California drought, the places that really need to get pounded is more the northern parts of California, because that's where the reservoirs are.
Yeah.
With El Nino, usually the storms are going to be more in the southern California area and into Arizona. So they're going to get a lot of rain, but it may not necessarily fill up their reservoirs, which is what they need.
What would it take to move El Nino further north, to get some of that pattern moving more northward? Snowpack is what we're talking about.
Yeah. And that's the other thing, is El Nino usually is associated with warmer waters, warm air, and less snow. So that's the other thing about being a drought buster. But to get more snow cover, basically what you got to have is more of the air coming in from northerly places as opposed from equatorial. With El Nino, the normal storm track is going to take it from the equatorial regions of the Pacific Ocean and push it right into Southern California and Arizona.
So to get big snowpack, you really need La Nina. Maybe, or no?
Yeah, I mean, there's no real good way to get snowpack in the western part of the United States. Because
that's been the problem, right, in the last several years.
And that's very much the truth. You need to have a combination of things. You need to have a good polar storm coming down at the same time that you get some good moisture coming up from the Pacific. And then those two have to meet right over the place that you want to dump that snow. We've had those occasionally in the past, but they're pretty rare events.
Which would be the Sierras and the Rockies and all of that.
Exactly.
Okay.
Exactly.
Let's, I want to roll this story. This is as of Friday. This is Jonathan Hunt taking a look at what's happening with Hurricane Patricia. take a look, and we'll talk to Randy more right after this.
Ominous clouds seen earlier today over Mexico's Puerto Vallarta resort area. Officials asking folks to leave for safer ground as the most powerful measured hurricane ever recorded in the Western Hemisphere bears down on the country's Pacific coast.
Anyone who lives very close to the beach should get basically as far away from that as possible, up to higher ground, into reinforced buildings.
Patricia's effects could be catastrophic as it hits Mexico with high winds, rough waves, and heavy rainfall. Officials declaring a state of emergency in many municipalities, and people working to reinforce windows and prepare sandbags during the storm's approach.
There will be, a substantial surge in flooding at the coast. There'll be, substantial wind damage.
The United Nations World Meteorological Organization says Patricia's strength can be compared to Typhoon Haiyan, that November 2013 storm, leaving more than 7,300 people dead or missing when it slammed into the Philippines, millions more displaced. Patricia will pose a threat to Texas even after it breaks up over land. What's left of the storm is expected to combine with heavy rain that's already falling in that area. In Los Angeles, Jonathan Hunt, Fox News.
Randy Cerveny, climatologist ASU and president's professor there, is our guest on Newsmaker Sunday. This is not a rainmaker for Arizona. This is going to move east and south of us.
Right. The moisture that occurred as it made landfall is now being pushed across Mexico so that by later today we're going to be dumping lots and lots of moisture.
Today being Friday.
Today meaning Sunday.
Oh, you're meaning, okay. Oh, you're ahead of me, man. Very good. Okay.
But yeah, today meaning Sunday, we're going to have lots and lots of moisture coming into Texas, and so you'll hear lots of reports about flooding and flash flooding that's going on in eastern Texas today.
You're a step ahead of me, man. You're a step ahead of me. All right, I want to go to tape N4 if we can. This is one of the things that we've been seeing lately. This is a video out of Wickenburg earlier this week. We had hail in Wickenburg. We've been getting our own series of storms. October is kind of, sometimes we have very dry Octobers. We've been getting a pretty good surge of, I don't know if Ellis can run N4. Can you find that? We're getting a lot of weather here. Look at this. I mean, this is, this looks like
incredible.
January.
This is, again, as much as I hate to sound like a broken record, this again is something that is very common that we would expect with El Nino conditions, because as the Pacific Ocean is really hot, air flowing over that brings moisture right over the southwest. Sometimes it goes into Texas, like the hurricane moisture is that's going to be happening this weekend, but we can also get it right over here into Arizona. So a lot of the moisture that we've been seeing both this summer and this fall and into the winter is going to be associated with the fact that the Pacific Ocean is so much warmer, particularly the eastern Pacific is so much warmer than it normally is.
Let me show you something. This is going to be N6, if we can cue this up. This was N6. This was video of a funnel cloud out of Morristown. Tell me what you see here. When we see this, I mean, this looked like the Wizard of Oz to us. This is not a big event, right? But it's...
Well, we get tornadoes here in Arizona. And by the way, whenever I see something like this, I generally assume, even though it may not look like it's touching down, remember that a tornado is a vortex. It's simply wind. And if there's nothing that's been picked up and sucked up to fill in that bottom part of the funnel, you just simply don't see it touching down.
So you think it probably is touching down?
It could be touching down. And what you would have to do is go out and check and see if there was any damage underneath of this. But when I'm storm chasing, I tell my storm chasers, hey, assume if you see a funnel cloud that it could indeed be a tornado and doing damage.
When that's happening, what is happening? What's causing it?
Well, what we have there is a massive amount of uplift that is causing a vortex to form in the atmosphere. Usually in order to do that, you need to have really, really strong winds up above, a jet stream up at 36,000 feet that's at least 150 to 200 miles an hour. When we had these big storms that caused that particular tornado, lo and behold, this far south, normally it's not this far south, we had a jet stream of that strength, and that helped to create the tornado conditions.
Are we in for a wet weather, do you believe?
Wet weather...
I'm sorry, wet winter. I misspoke. No. Do you believe we're in for a wet winter?
Absolutely, absolutely. I think that this is going to be something that we will see a whole bunch of these kind of storms. It's not going to rain every day, and it's not going to be...
It's Arizona.
It's Arizona. but we're going to have a lot more of these than we would normally have. Normally we get during the wintertime maybe 1 or 2 big storms that might hit us. This year I would probably say 5 or 6 big storms are going to happen between now and say next March or April.
It strikes me, I've been here since 1978. You've been here how long?
About the same.
Okay. We had that period in the late 70s, early 80s where we got dumped on. I mean, the Salt River was spilling its banks. It was unbelievable. We've had these periods. It feels like we get these every 20 or 30 years where we go through wet and dry periods.
And there have been a lot of researchers, particularly the tree ring laboratory down in the University of Arizona has done a lot of research looking at tree rings and looking for cycles that might happen in the precipitation here in the Southwest based off of tree rings. And they see drought in the 30s, they see drought in the early 50s, they see drought in the early 70s, they see drought in the early 90s. And so, yeah, there does appear to be some cycle-like formation in the precipitation that we commonly see out here in the Southwest.
So we go through these periods of drought and normal or even wet.
Right. It's like we don't like to have moderate conditions. We either go to one extreme or the other. So.
And then you create from those extremes your median.
Yeah.
Right? And that's the thing.
Right. Which usually then doesn't mean much because median means it's just happening half the time, but if we're at extremes, we're never really going to be at the median. We're either going to be above it or below it.
That's the point I was trying to get to. The median is really the place where you're at very little.
Right.
You're dealing with extremes that averaged out put you there.
Exactly.
But being there is not very frequent.
Right.
Okay, got it. Randy Cerveny, our guest this week on Newsmaker Sunday. We're talking weather. We're going to talk climate change in part 2 of this discussion. And what's in for Arizona? Are we getting out of perhaps a drought condition here? We'll talk about it with Randy Cerveny, climatologist from ASU, when we come back. Back on Newsmaker Sunday, climatologist Randy Cerveny is our guest. As we talk about kind of what's happening weather-wise, it's been a pretty wet summer, late summer, fall here.
Yeah.
We've been getting a series of storms.
Yeah, the monsoon is always a hit and miss type of thing. So when we look at the records for this summer, we can see that there are some places that got absolutely slammed by the monsoon.
Exactly.
Wickenburg.
Right.
We can look at other places that hardly got a touch by it. Carefree, didn't get very much rainfall at all this particular monsoon season. So depending on where you were, you may say, oh, this was one of the best monsoons we've ever seen, or one of the worst. Because it's very much a hit and miss thing. The kind of storms we get out of the monsoon are not going to cover the entire valley. They're going to be hitting one place and not another place.
Right.
It just is more the luck of the draw.
And the guy who has to field those phone calls is my friend Dave Muncie over there because,
Exactly.
we're doing all this weather coverage and then people are calling Dave and going, what are you talking about? There's no rain out here at all. Well, there may not be where you live, but there is rain in other places. But we have had a pretty good monsoon event this year, right?
Yeah, if you sum up across the state and even at Sky Harbor itself, we had a better than average monsoon.
Can we show N7? This is video from Sky Fox last week. We saw this repeated all over the valley. When we're in this part of the year, this isn't monsoonal, is it?
No, it's not.
What is this that we see? It looks like a monsoon, but it's not.
Yeah, what happens is that we have a transition. The way the monsoon normally works is that we have...
Look at that rain cell, by the way. Look at that rain coming down.
Just incredible. Wow. Here. When the monsoon is going on, what we have is a change in wind direction, so that during our summertime, we're primarily getting wind flow that comes up from Mexico and dumps a lot of moisture from the Gulf of California and from the Pacific Ocean into our particular area. In the wintertime, what tends to happen more is that we're getting polar storms. We're getting storms that follow the jet stream, come this far south, tap into moisture that comes up from the Pacific, and then creates colder storms than what we would have with the monsoon. So it's a different mechanism. There are different kinds of storms.
As rainmakers, which ones are more significant?
In terms of intensity, the monsoon thunderstorms, the convective heat-based storms are usually the ones that can produce very, very heavy amounts of rain in a short period of time, like we saw in Wickenburg. Right. The better storms from getting out of a drought perspective are going to be the kind that are associated with wintertime, where there are some that are formed by cold fronts that come through, where the whole valley, the whole state of Arizona gets a line of thunderstorms that works its way across the state, because that can dump out rain across the whole area.
We are right now out of a drought condition statewide pretty much.
Yeah, we're in still drought, but we're not into the severe extreme droughts.
Right.
Yeah. So we have seen marked improvement because of this monsoon.
And because of what's happening with El Nino, warming of the Pacific, you believe we're going to get a fair amount of rain this winter?
Yeah, all indications are that we should. Now, with that saying, we're forecasting, and forecasting is inherently a dangerous profession to be in. But about 70% of the time when we have a big El Nino like we're going to have, we get above normal rainfall in the wintertime here in
And this
Arizona.
El Nino stacks up in the top 3 of the past 100 years?
Or maybe even number 1 by the time we're all done. It's still developing, so it's going on right now, but it probably is not going to get to its max until probably December.
Let's cue up N8. I want to show a video of something, I'd never heard of it before, but I'm sure you had, a gust-nado. This was like haboob and grapple. Those terms I'd never heard of. Now this is another one. Gust-nado has come into our lexicon. What's a gust-nado?
Well, this is a beautiful classic image of a gust-nado. A gust-nado is where you get the outflow coming out of a thunderstorm, and as you saw there, they panned over and showed you the thunderstorm that created this. You'll get that haboob-like winds coming out of that, and as it interacts with the storm above it, it starts to rotate. And so it's got some of the characteristics of a tornado, some of the characteristics of a downburst
dust
devil type of thing.
Okay.
And so it's called a gust-nado, and it can be dangerous because the winds in it can be upwards of 100 miles an hour.
No kidding. I had no idea.
But luckily they're pretty rare, and to get a good, beautiful image like this is a pretty rare thing.
Okay, I'm in your class at ASU. I have a very stupid question, but I'm not kidding. I have never seen, particularly in Tucson, raindrops the size we get in Arizona. What is the deal? I feel like the raindrops here are bigger than anywhere I've ever lived. Am I imagining this?
No, I think they are pretty big.
Why would that be?
Well, it's one of the interesting things. In order to get a raindrop, a lot of people don't realize it, you need to have stuff in the air. You've got to have actually some kind of pollution.
Dust.
Dust is a great, what we call condensation nuclei, because water can't collect on itself. You've got to have it collect around something.
A binding agent.
If you will, yeah.
Okay.
And so in around coastal areas, sea salt is a great condensation nucleus. Out here, dust is. It's one of the reasons why after a big storm, you look at your car and you think, well, it's dirty. Why should it be dirty after a big storm? It's because each one of those little raindrops has millions of little particles of dust that the water is collected around.
You're not going to flunk me.
No, you're going to get an A for the day.
There are no stupid questions, right? All right, now we talked about forecasting. Forecasting right now, weather-wise, despite 10-day forecasts, is really good for about how many days? Dave's going to kill me for this. He's laughing over there. Dave's in the studio right now. How far can we really legitimately look out there and forecast?
The National Weather Service has a pretty good accuracy up to about 4 days out now. We can get ideas on temperature and precipitation with about 80% accuracy out to about 4 days into the future.
Okay, with that in mind, with that science in mind, how can we accurately know what's happening with global warming?
Because they're two completely different beasts. The kinds of things that we use to forecast day-to-day weather are different from the kinds of things that we have to do to forecast what's going to happen next year or next decade. That when we're forecasting day-to-day temperatures, we don't have to worry about what the Pacific Ocean is doing for the most part. We don't have to worry about what the Arctic ice pack is doing. But when we're looking at climate change, what's going to happen next year, next decade, that type of thing, those things become of critical importance. So a weather model and a climate model turn out to be two very different kinds of beasts.
So the fact that predicting weather is not, you can't go out much more than 4 days, right?
Right. We've gotten better. And so, yes, we can take it out to 10 days now. With
really? So Dave's 10-day is deadly accurate, by the way.
Well, with less accuracy as we go along.
Sure, of course.
There turns out to be an actual limit, though, to how far you can take out a weather model.
Okay.
Weather models really don't work very well at all beyond 14 days.
We are warming, though.
We are warming.
No doubt about that.
On the globe, no, there is no doubt about that.
And where the weather stations are located, you're comfortable with where they're located and that we're getting an accurate sample?
Well, that's one of the complaints that we have, is that we have weather stations where there are people. And we have to make assumptions about what's going on in places where we don't have weather in order to put the data into a climate model. Sometimes that can be erroneous. For example, in Antarctica, that's a big area. It's the size of the United States. But we have to have detailed information in order to run the climate model. Well, we don't have a lot of weather stations down in Antarctica. Think of it, it would be like having a weather station at San Diego, at Seattle, at Kansas City, at Miami, and at New York. That's about how many weather stations we have down in Antarctica.
So it's hard to get a true picture. Why is the ice cap north melting but in the south growing?
That's
if we're warming.
Yeah, you are quite right. It is one of the weird things is that this sea ice in the northern hemisphere has gotten smaller and smaller each year for the last few years. Down in the south, in Antarctica, it's been the exact opposite. We've had some record high sea ice amounts. We don't know why. It's one of the things that we are looking at. There has been some speculation that it might be due to the melting of parts of Antarctica, but there's nothing really conclusive about that.
Randy Cerveny is our guest this week on Newsmaker Sunday, climatologist with ASU and President's Professor. That's the right way to put it.
That is it.
That is top of the heap. We're back with Randy right after this. Back with climatologist, ASU climatologist, and President's Professor Randy Cerveny, talking the weather, and we've had quite a bit of it, and also talking climate change earlier. If we're talking climate change for a minute, and we're going to hear a lot of discussion about this in the political season, is there anything we can do, really, without spending trillions to stop this?
Well, for one thing, I'm a scientist as opposed to a politician.
Right.
So I'm looking primarily at the data and trying to figure out whether our numbers are actually correct or not. And that's something that we're continually updating and continually evaluating.
Are you confident in the numbers?
Actually, getting more and more confident all the time.
Okay.
But in terms of what to do about it, well, I think one of the best ideas that has come out in recent times, and to kind of toot our own horn, it's kind of something that ASU has done. We've developed something called the School of Sustainability,
right,
which is the idea of trying to not only maybe limit our impact on the environment and our changes that might occur because of that impact, but also to learn to live with our environment so that we can use things to the best capability of both humans and the environment. And so I think things like the School of Sustainability have done a really good job at leading us into the future, whatever that future may be.
Given that we live in a desert, Arizona is probably uniquely prepared to handle this in the system that was set up in the early 1900s, the Salt River Project, or the Salt River chain of reservoirs.
Absolutely. It was an ingenious thing. I don't know whether it could have been done today in today's political world or not.
There's no way. I mean, California now, they're talking about tearing down reservoirs.
Exactly. But this was such a brilliant idea. It's SRP being both a public and a private type of situation where the government helped finance the original development of these dams. The original farmers that were in the area put up their land for collateral. It was a brilliant idea. And it's worked so well. I mean, we've gone 100 years here with almost no impact in terms of our water usage, even though we live in a place where we get substantially less water than what we use.
And in fact, we are, in terms of people and usage of water, we hit our peak of water usage despite the growth in the 80s.
That's right. I mean, we still use a lot more than what we get. I mean, the annual rainfall that we get here in the metropolitan area is around 8 to 9 inches. We use water more on the order of about 25 to 30 inches a year per person to make that work. But the nice thing is the system has worked. We hold on to that wintertime moisture through those dams and then pump it into us as we need it. It's brilliant.
What, 30 seconds, what do you see coming this winter?
I see actually a helpful recharge of a lot of those systems that we're going to start to fill up those reservoirs.
That be Lake Mead also?
I'm sorry?
Lake Mead also?
To a lesser extent. The trouble with El Nino is it tends to be more in the southern states and not so much into Colorado or Northern California. So they'll get some benefit.
Yeah,
but
let's hope, because it's down a bunch. Good to see you.
And
Randy Cerveny, ASU. Go Devils.
Indeed.
We'll see you next week on Newsmaker Sunday.